But this notation that you're looking at where the cursor is blinking is a little awkward, right? Because you have to sort of struggle to work out that what we're doing here is making a temporary variable, d, and giving it a value. Because the name d is buried up here, and it's not until we get down here that we find out what d is supposed to be. So Scheme provides what's called syntactic sugar, a notation that isn't really necessary. We could use this notation, but it's nicer to have a notation that's a little more human readable. So we rearrange that lambda and the procedure call like this. So here's let. Let is one of the places where parentheses mean something special. So it's let, and then bindings, and then body. That's what a let looks like. Bindings is parenthesis, and then a binding, and then another binding, however many bindings you want. So that's what bindings looks like. And a binding is parenthesis name. Oops, I didn't want that in yellow. I just wanted the parenthesis in yellow. Name and value expression. Close parenthesis. So 2 levels of special parentheses in a let. One of them delimits all of the bindings, and the other one delimits an individual binding. So luckily there's Emacs. Out here, we have 5 close parentheses, one after the other. The innermost 3 of those are ordinary parentheses closing function calls. So this one is closing the call to times for times 4AC. This one, whoops. This one is closing the call to minus for minus b squared 4AC. This one is closing the call to square root. And then the 2 special ones. This one is closing the binding for d, and this one is closing the collection of bindings. In this case, there's only one binding, so that seems redundant. But we'll see in a moment you can have more than one binding. And then after that comes the body, which typically is a single expression, although we'll see a bit later in the course that you can have more than one sometimes. Which is why we need to delimit the bindings, because that whole first thing is bindings, and then expressions that come after that are the body. But for our purposes right now, there's only going to be one expression in a body, the one that says what value this function is returning. So here's the example with more than one variable in the let. So this parenthesis is for the entire collection of bindings. This is for the d binding. This is for the minus b binding. That's a symbol. Don't be fooled. It's not an operation. And this is the 2a binding. That's also a symbol. These are actually illegal scheme symbols, because things that start with digits or minus sign are supposed to be numbers. But STK lets me get away with it. And then the body actually is really nice. It's square root of, I'm sorry, not square root of, it's minus b plus d over 2a and minus b minus d over 2a. Okay? So that's let. So again, the reason that let is useful is that it lets you put the symbol that you're defining, d, right next to the expression that provides its value. So that's a rearrangement that makes this program easier to read. But all let is, absolutely all that let is a rearrangement of a lambda to create a procedure. So this would be lambda of d minus b and 2a, and then sentence blah, blah. So that lambda expression. And around that, a procedure call that gives the actual arguments, which are square root of blah, 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 negative of b, and times 2a. So the stuff in yellow is just an ordinary procedure call. The stuff in white is the lambda expression that creates the procedure that the procedure call calls. And all of that is equivalent to the let that you see on the screen. So what happens if I say let a be 5 and b be times 2a and then the body of the let is, I don't know, sentence AB? What's going to happen? Who thinks I'm going to get 510? One brave person. What else? Two brave people. Okay, here we go. I get unbound variable a. Where I got that message, you can see later on in the error message that times 2a. I was doing this computation when there wasn't a value for a. So if you just look at the let and don't remember how it works, you're going to think that this is like, in that language you learned in high school, a equals 5, semicolon. B equals 2 times a, right? That it's an assignment one after another. It's not like that. It's a procedure call. So that let that I wrote, I make the procedure lambda of AB, sentence AB, and I call that procedure with the arguments 5 and times 2a. So in a procedure call, what's the first thing we do? Come on. You know this. Yes? Yeah, evaluate all the sub-expressions. So we evaluate this sub-expression and we get a procedure. We evaluate this sub-expression, we get 5. What's A? A isn't anything yet, because only after we evaluate all the sub-expressions do we actually call the procedure with the argument values. When we call the procedure, whatever the value of B is gets substituted in here. Or, I'm sorry, whatever the value of A is gets substituted in here. But there isn't a value for A at the time we're evaluating this. Okay, so in a let, you can't think of the assignments as happening sequentially. You have to think all the value expressions get evaluated, and then all the bindings are done all at once. And then we evaluate the body. Okay? Also, these variables only exist inside the body because they're formal parameters to a procedure. So A and B only exist inside what's in white on the board here. Right, so it's not like define which if I type, define A5 to scheme at the scheme prompt, it's going to make a permanent association of the name A with the value 5. But this doesn't. This just does a procedure call which says substitute the actual argument values for the formal parameters in the body. Okay?